On the morning of June 6, 1944, at exactly 6:15, a young German soldier named Grenadier Hinrich Severloh took his position behind an MG-42 machine gun. His vantage point overlooked what the Allies called Omaha Beach. The air carried the sharp scent of sea salt, mixed with diesel fumes, drifting from ships in the distance. A thin layer of fog hugged the surface of the English Channel. Severloh was just 20 years old at the time, originally a farm boy from Lower Saxony who'd been conscripted into the Wehrmacht 2 years prior. His training had been as an artilleryman, yet somehow he found himself manning an infantry position along the Normandy coastline. As he checked his weapon, his hands remained remarkably steady. The ammunition belt was loaded properly, the barrel locked into place, and the sights were carefully aligned toward the waterline. Far below. During his training, he'd fired countless practice rounds through thousands of repetitions. What he'd never done was aim at another human being. Hidden in the darkness before dawn below his position, the most massive invasion fleet humanity had ever assembled was making its way toward the Norman coast. The armada consisted of more than 5,000 ships, 11,000 aircraft, and 156,000 soldiers. What the Allied forces were attempting was the most daring amphibious assault ever conceived in military history. The position where Severloh sat was designated as Widerstands Nest 62, which translates to Resistance Nest 62. It was essentially a concrete bunker carved into the bluffs, rising above the sandy beach. The Germans had designed these positions specifically to create overlapping fields of fire, turning any attempt to land on the beach into a massacre. Severloh's bunker was positioned roughly 40 meters above the level of the sea. From there, he commanded a completely unobstructed field of fire spanning the entire eastern portion of Omaha Beach. That meant nearly 2,000 meters of wide-open sand lay exposed beneath his gun. The weapon was loaded with belted ammunition, 7.92 millimeter rounds, which was the standard German infantry cartridge. This was the same ammunition the Wehrmacht had been using since the beginning of the century. Beside his firing position, thousands of rounds were stacked in metal ammunition boxes. His assistant gunner stood ready to continuously feed belt after belt into the hungry weapon. As dawn broke, the landing craft began to materialize from the gray water, looking like gray shadows emerging from the gray sea. Through his binoculars, Severloh could hear the low drone of their engines mixing with the rhythmic crash of waves against the shoreline. Watching through his field glasses, he could make out the shapes of soldiers packed tightly inside the craft, standing in neat rows, all of them waiting for the moment when the ramps would drop. The first ramps fell at approximately 6:30 in the morning. American soldiers poured out into the surf. Each man was burdened with roughly 60 pounds of equipment strapped to his body. They had to wade through water that frequently reached their chests. Every single one of them was completely exposed to fire from above. On that beach, there was absolutely no cover, no shelter whatsoever from the guns positioned on the heights. Severloh squeezed the trigger. The MG-42 roared to life with its unmistakable sound. It produced a sustained, tearing roar, completely unlike any other weapon found on any battlefield. Firing at 1,200 rounds per minute, individual shots became impossible to distinguish from one another. The gun simply screamed without pause. What unfolded over the following 9 hours would earn Severloh a terrible nickname, the Beast of Omaha. However, the weapon that made such devastation possible had a history that began years earlier in a factory that had absolutely nothing to do with making weapons of war. The MG-42 wasn't designed by weapons experts or specialists. It wasn't manufactured by some prestigious arms company with generations of experience behind it. Instead, it was created by mechanical engineers who knew virtually nothing about machine guns. These men worked for a company whose main product was sheet metal lanterns. The factory was located in a provincial Saxon town that most Germans had never even heard of. The lead designer had never fired a weapon in actual combat. He'd never served in any military capacity whatsoever. His expertise was in manufacturing processes, not in the science of killing. And yet what he created became the template for nearly every general-purpose machine gun that came after it. This includes weapons that are still being used by armies all around the world today, more than 80 years after the design first appeared on battlefields. Direct descendants of his original design are being carried by soldiers on every continent right now. This is the story of how a manufacturing innovation that saved roughly $100 per weapon ended up changing the entire way wars are fought. This is the story of the MG42. The problem actually began with the MG34. Back in 1934, the German military introduced what they called the Einheitsmaschinengewehr, which means the universal machine gun. The concept itself was genuinely revolutionary for its time. Previous military thinking had maintained strict, separate categories for different machine gun roles and purposes. Light machine guns were designed as portable weapons that infantry squads could carry for mobile operations. Heavy machine guns were crew-served weapons mounted on tripods, intended for sustained fire from fixed defensive positions. Aircraft machine guns were specialized designs specifically optimized for aerial combat conditions. Anti-aircraft guns had their own unique set of requirements. German planners proposed something completely different from all of this. They wanted a single weapon that could fulfill all these roles simultaneously. One gun that infantry could carry using a bipod, that could be mounted on a tripod for sustained fire, that could be installed in vehicles and aircraft, and that could be used for anti-aircraft defense. One design, one training program, one unified logistics chain. The result of this thinking was the Maschinengewehr 34, known simply as the MG34 at the time of its introduction. It was arguably the most advanced automatic weapon anywhere in the world. The MG34 was an air-cooled, recoil-operated weapon, chambered for the standard German 7.92 by 57 mm Mauser cartridge. It fired at approximately 850 rounds per minute, which was significantly faster than comparable British or American machine guns of the era. It fed from 50-round belts that could be linked together for sustained fire, or from 75-round saddle drum magazines for mobile operations. The weapon featured a quick-change barrel system that was quite innovative. A properly trained gunner could swap out barrels in under 15 seconds, which allowed for sustained fire without the weapon overheating. The sights were fully adjustable for both range and windage. The trigger mechanism permitted both semi-automatic and fully automatic fire modes. Most importantly, for its intended purpose, the MG34 could adapt to multiple roles through different mounting systems. When mounted on its integral bipod, it functioned as a light machine gun. When placed on the Lafette tripod, it transformed into a medium machine gun capable of delivering accurate fire at ranges exceeding 1,000 meters. Special mounting systems allowed it to be installed in tanks, armored vehicles, and aircraft. The German military took great pride in the MG34. They genuinely believed it gave them a significant tactical advantage over potential adversaries. In many ways, they were absolutely correct in this assessment. But the MG-34 had one critical flaw that wouldn't become fully apparent until Germany began making serious preparations for major warfare. The weapon was extraordinarily difficult and time-consuming to manufacture. The MG-34 was truly a machinist's weapon through and through. Nearly every single component required precision machining from solid steel billets. The receiver had to be milled from a single block of high-grade steel. The bolt assembly alone contained dozens of precisely fitted parts that had to work together perfectly. The barrel extension, the feed mechanism, the trigger group, all of these demanded the attention of highly skilled craftsmen using expensive machine tools. Each individual MG-34 required approximately 150 man-hours to manufacture. That meant a single worker operating full-time could produce perhaps just one weapon per month. In actual practice, production was divided among specialists working at different stages of the process, but the total labor investment remained essentially the same. The cost came to 327 Reichsmarks per unit. At contemporary exchange rates, that was roughly equivalent to 130 American dollars. To put that figure in proper perspective, an average German factory worker earned approximately 150 Reichsmarks per month. A single MG-34 cost more than 2 full months of an ordinary worker's wages. The weapon also consumed 49 kilograms of raw materials, primarily high-grade steel alloys containing metals that Germany had to import from other countries. As political tensions increased throughout the late 1930s, access to those strategic materials became increasingly uncertain. Most critically, from a strategic standpoint, the MG-34 demanded skilled labor that was in desperately short supply. Germany certainly had excellent machinists and tool makers, but their numbers were finite and limited. Every single machinist working on MG-34s was a machinist who wasn't working on aircraft engines, tank components, artillery pieces, or any of the 1,000 other precision parts that modern military equipment required. The Wehrmacht leadership recognized this fundamental problem. Staff planners calculated their machine gun requirements based on planned force structures and compared those numbers to actual production capacity. The numbers simply didn't match up. Germany could not manufacture enough MG-34s to properly equip the army they were building. In February 1937, the German Army Weapons Agency issued a formal request for proposals. They wanted a new universal machine gun that could match the MG-34's combat performance while being significantly easier and less expensive to produce. 3 companies received development contracts to compete for the design. 2 of the selected companies were obvious choices that made perfect sense. Rheinmetall Borsig of Düsseldorf was one of Germany's premier weapons manufacturers. The company had been building military equipment since the 19th century. They possessed extensive experience with machine guns, artillery, and armored vehicles. They had the engineering talent, the production facilities, and the institutional knowledge necessary to develop a completely new weapon system. Steyr Daimler Puch of Austria was another well-established arms maker. They had produced military equipment for decades and maintained strong, long-standing relationships with the German military procurement system. The third company that received a contract was completely unexpected and raised many eyebrows: Metall- und Lackierwarenfabrik. Johannes Grossfuss was located in Döbeln, a small town in Saxony with a population of roughly 20,000 people. The company name translated directly to Metal and Lacquerware Factory, Johannes Grossfuss. Their primary business was manufacturing pressed and stamped sheet metal components for civilian use. Their signature product, The thing they were known for was lanterns. They had never designed a weapon of any kind whatsoever. They had no experience with military contracts. They had zero reputation in the arms industry. What they did have, however, was deep expertise in a manufacturing process that the traditional weapons companies had largely ignored and dismissed. They knew exactly how to stamp metal efficiently. The man who was tasked with leading their machine gun development project was Dr. Werner Gruner. He was 33 years old, a mechanical engineer who specialized in mass production techniques rather than weapons design. Gruner had been born on June 7, 1904, in the village of Döbeln, a tiny community that would eventually be absorbed into the larger town of Kolditz. Gruner's father worked as a school teacher. The family wasn't wealthy by any means, but they placed tremendous value on education. Young Werner showed early aptitude for technical subjects and mathematical thinking. He attended the Real Gymnasium in Döbeln, which was a type of secondary school that emphasized mathematics and science over classical studies. In 1923, he completed his secondary education in Leipzig and enrolled at the Technical University of Dresden. He studied mechanical engineering from 1923 to 1928, focusing specifically on manufacturing processes and production efficiency rather than design theory. He completed his doctorate and remained at the university as a research assistant for 2 additional years, deepening his expertise in mass production techniques and industrial processes. In 1930, he joined Grossfuss as a technical designer. Gruner knew absolutely nothing about weapons or weapon systems. He had never served in the military in any capacity. He had never fired a machine gun or any automatic weapon. His expertise was entirely in stamping sheet metal into useful shapes, using hydraulic presses and relatively simple tooling. This apparent disadvantage, this complete lack of traditional weapons knowledge, would actually prove to be his greatest asset in solving the problem. The other 2 companies that received contracts approached the problem exactly like weapons designers would. They tried to improve upon existing designs, to refine and optimize the mechanisms that had worked in previous machine guns. They focused on ballistics, metallurgy, and combat performance characteristics. They assumed from the start that a machine gun had to be built using traditional methods, with machined parts made from solid steel billets. Gruner approached the exact same problem like a manufacturing engineer, rather than a weapons designer. He asked a fundamentally different question. Instead of asking how to make a better machine gun, he asked how to make a machine gun that was better suited to mass production. Before beginning his actual design work, Gruner made an unconventional decision that surprised his colleagues. He enrolled in a German military machine gun course as a regular student. For several weeks, he trained alongside actual soldiers, learning to operate the MG-34 in the field. He fired thousands upon thousands of rounds through the weapon. He learned exactly how gunners carried their weapons in combat, how they set up firing positions under pressure, how they fed ammunition belts smoothly, and how they changed overheated barrels quickly. He paid careful attention to things that traditional weapons designers might overlook or dismiss as unimportant. How did soldiers actually maintain their weapons in field conditions? What specific parts broke most often under real-world use? What procedures took too long when time was critical? What could go wrong during actual combat that wouldn't show up in controlled testing? He talked extensively with experienced gunners about their frustrations with the MG-34 in actual combat use. They told him about the weapon's sensitivity to dirt and dust, which could cause jams at critical moments. They complained about parts that were difficult to replace in the field without specialized tools. They described specific situations where the weapon had failed them exactly when they needed it most. Then Gruner returned to Dublin and started designing from absolute first principles, questioning every assumption. Traditional machine guns used precisely machined parts made from solid steel billets. A skilled machinist would start with a block of high-grade steel and carefully remove material through cutting and milling until the desired shape emerged from the block. The process was slow, expensive, and required highly skilled craftsmen at every single stage of production. It also wasted enormous amounts of steel that Germany desperately needed elsewhere. Much of the original billet ended up as metal shavings, scattered across the machine shop floor, completely useless. Gruner proposed something that seemed radical to weapons experts. He would build a machine gun primarily from stamped sheet metal components, using the exact same techniques that Grossfuss used to make lanterns and other civilian products. Sheet metal stamping worked in a fundamentally different way than traditional machining processes. Instead of removing material from a solid block through cutting, stamping pressed a flat sheet of metal into three-dimensional shapes using hardened steel, dies, and hydraulic pressure. The process was remarkably fast. A hydraulic press could form complex shapes in mere seconds rather than hours. The parts that came out required minimal finishing work. They could be produced by relatively unskilled workers following simple, standardized procedures. Stamped parts also used material far more efficiently than machining. There was very little waste in the process. A flat sheet went into the press. A finished component came out the other side. Nearly all the metal ended up in the final product rather than on the floor. Surprisingly, to many people, stamped parts were actually quite strong structurally. The stamping process compressed and work-hardened the metal, actually increasing its strength. A properly designed stamped component could easily be stronger than a machined equivalent made from the exact same grade of steel. The weapons experts and traditional designers were deeply skeptical of this entire approach. They believed that a stamped metal machine gun would be flimsy, unreliable, and prone to catastrophic failure under the extreme stress of rapid automatic fire. They pointed out that the forces involved in automatic weapons operation were absolutely enormous. Thousands of pounds of pressure repeated hundreds of times every single minute. Surely stamped sheet metal couldn't possibly handle such brutal, sustained abuse. Gruner and his team set out to prove the skeptics completely wrong. Working with a small team that included a talented small arms designer named Kurt Horn, who had previously worked at Mauser, Gruner developed a completely new machine gun design built almost entirely from stamped steel components. Only the most critical, highest stress components would be machined from solid steel. That meant the barrel, the bolt, and a few other high-stress parts. Everything else in the weapon would be stamped, pressed, riveted, and spot-welded together. The design incorporated a unique operating mechanism that was quite different from existing weapons. Instead of the rotating bolt system used in the MG30 Ivor, the new weapon used an innovative roller locking system. Two cylindrical rollers in the bolt head engaged matching recesses machined into the barrel extension. When the weapon fired, gas pressure pushed the bolt rearward, but the rollers mechanically prevented it from opening until the bullet had completely left the barrel and pressure had dropped to safe levels. Then the rollers were cammed inward by shaped surfaces, unlocking the bolt to cycle backward and load the next round automatically. The roller locking mechanism was elegant, reliable, and particularly well-suited to stamped construction methods. It would later go on to influence numerous other weapon designs around the world. By October 1937, all three competing companies submitted their design proposals to the Military Evaluation Board. Rheinmetall-Borsig and Steyr both offered gas-operated designs based on conventional machining approaches and traditional thinking. Grossfuss submitted something completely different that challenged every assumption. The evaluation board examined all three proposals carefully and thoroughly. They assessed performance specifications, manufacturing requirements, and projected costs for mass production. The decision wasn't even particularly close. The Grossfuss design was selected for further development and testing. The lantern makers had beaten the established weapons manufacturers at their own game. The initial trials of the Grossfuss prototype in April 1938 revealed several areas that required improvement and refinement. The feed mechanism needed significant refinement to handle ammunition reliably. The barrel change system wasn't fast enough for combat conditions. Some components showed excessive wear during extended firing tests that simulated combat use. Gruner and his team returned to the factory and addressed each issue systematically and methodically. They tested modifications, made adjustments, retested, and modified again in continuous cycles. They deliberately kept the design similar to the MG-34 in external appearance and handling characteristics. This similarity was completely intentional and carefully planned. Soldiers who were already familiar with the MG-34 could transition to the new weapon with minimal additional retraining time. More importantly, the mounts, accessories, and support equipment already developed for the MG-34 would work perfectly with the new gun. By February 1939, the improved prototype, which was designated the MG-39 during development, was ready for extended testing under demanding conditions. The results exceeded absolutely all expectations. The stamped steel construction, which critics had confidently predicted would fail catastrophically, proved more robust and reliable than the precision-machined MG-34. The new weapon was significantly less sensitive to dirt, dust, and debris contamination. It tolerated the kind of brutal abuse and neglect that caused the temperamental MG-34 to jam at critical moments. It kept firing reliably in conditions that stopped other machine guns cold. Extensive tests in sand, mud, and extreme temperatures showed superior reliability across the board. The stamped components actually flexed slightly under stress, rather than cracking like more rigid machined parts. The looser tolerances that came with stamped construction actually helped rather than hurt performance. They allowed the mechanism to continue functioning even when fouled with debris that would jam a precision weapon. The production numbers told a compelling story all by themselves. The MG-34 required 150 man-hours to manufacture from start to finish. The new Grossfuss design required just 75 man-hours. That was half the labor for the exact same firepower. The MG-34 consumed 49 kilograms of raw materials per weapon produced. The new design used just 27.5 kilograms. That was nearly half the steel, freeing up enormous quantities of strategic materials for other military uses. The MG-34 cost 327 Reichsmarks to produce. The new weapon cost 250 Reichsmarks. That was a 24% cost reduction that would save millions as production scaled up to wartime levels. But those impressive savings came with something else, something that would absolutely terrify Allied soldiers for the entire rest of the war. The new gun fired faster than any infantry weapon in existence anywhere in the world. The MG-34's rate of fire was approximately 850 rounds per minute. That was already considerably faster than Allied machine guns, which typically fired somewhere between 450 to 600 rounds per minute. The Browning M1919 that American forces used fired at roughly 500 rounds per minute. The British Vickers guns were similar. The new Grossfuss design fired 1,200 rounds per minute. Some variants would eventually reach 1,500 rounds per minute. This blistering rate of fire was completely deliberate and carefully planned. German tactical doctrine placed heavy emphasis on suppressive fire. That meant the ability to keep enemy soldiers pinned down, unable to move, while assault troops maneuvered to better positions. Military analysts had carefully studied combat footage and motion pictures and concluded that targets were typically exposed for only very brief moments as soldiers moved quickly between cover positions. Maximum bullet density during those brief windows of exposure was absolutely essential for effectiveness. A weapon firing at that blistering rate put twice as many bullets on target in the same time period as one firing 600 rounds per minute. In the critical seconds when an enemy soldier was exposed and vulnerable, that difference could be absolutely decisive between hitting or missing. The engineering challenges involved were absolutely immense and daunting. At 1,200 rounds per minute, the gun cycled 20 complete times every single second. The bolt traveled back and forth faster than the human eye could possibly follow. Enormous mechanical forces were generated and absorbed with each cycle of operation. The barrel heated rapidly from the continuous friction of bullets passing through the rifling at high velocity. Gruner and his team solved each challenging problem methodically and creatively. They designed a quick-change barrel system that allowed a properly trained gunner to swap barrels in under 6 seconds. A simple lever on the side of the receiver unlocked the barrel mechanism. The gunner wore an asbestos glove to grasp the extremely hot barrel and pull it free from the receiver. A fresh barrel slid smoothly into place and locked automatically without any tools. With sufficient practice and training, gunners could change barrels without interrupting their observation and engagement of the battlefield. They developed a feed mechanism that pulled ammunition belts smoothly and reliably at the extreme cycle rate. The feeding system used a roller-driven arm inside the receiver cover that moved rapidly back and forth with each cycle, advancing the belt 1 round at a time with perfect timing. The mechanism was so reliable and efficient that it became the template for numerous future weapon designs. They engineered a weapon that could sustain fire rates that would have literally destroyed any previous machine gun design. Where other weapons would overheat, jam, or simply shake themselves apart from the vibration, the MG-39 just kept firing reliably. A limited production run of approximately 1,500 improved weapons, designated the MG-39-41, was completed in 1941 specifically for combat trials in actual field conditions. German infantry units tested the weapons in real combat conditions on the brutal Eastern Front against Soviet forces. The field reports that came back were enthusiastic across the board. Soldiers absolutely loved the new gun. It was noticeably lighter than the MG-34. It was more reliable under harsh conditions. It was easier to maintain in the field, and the rate of fire was absolutely devastating against enemy infantry. In early 1942, the German military officially accepted the design for full production at multiple factories. Manufacturing contracts went to Grossfuss, Mauser, Gustloff Werke, Steyr, and other manufacturers with suitable facilities. The weapon entered mass production as the Maschinengewehr 42, the MG-42. In May 1942, the MG-42 saw its first significant combat action against Allied forces. The German Afrika Korps deployed the new weapon during the Battle of Gazala in Libya. British troops encountered something they had literally never experienced before: on any battlefield. A machine gun that sounded completely unlike anything else they'd ever heard. The human ear simply cannot distinguish individual shots at that cyclic rate. The human brain cannot process 20 separate discrete sounds per second. Instead of the familiar rat-tat-tat of conventional machine guns that soldiers recognized, the MG-42 produced a continuous tearing sound, exactly like heavy fabric being violently ripped apart. British soldiers said it sounded like thick cloth ripping. Others compared it to a buzzsaw cutting through hard wood. The nicknames followed very quickly. British troops called it the Spandau, which was a carryover nickname from the First World War. German machine guns had been manufactured in the Spandau district of Berlin back then. American soldiers called it Hitler's buzz saw, which became its most common nickname. Soviet soldiers fighting on the Eastern Front called it the linoleum ripper because of the way the sound reminded them of flooring being torn up. German troops had their own colorful names for their weapon. They called it the Knochensaga, which means the bone saw for the horrific damage it inflicted on human bodies. They called it Hitler's Säge, or Hitler's saw. They called it the Singende Säge, which translates to the singing saw because of the distinctive high pitch of its firing sound. By mid-1942, the MG-42 was being deployed on all fronts where German forces were engaged. Production ramped up with impressive speed, despite growing Allied bombing campaigns. German factories produced 73,995 MG-42s in 1942. Keep in mind, that was only a partial year of production. That number jumped dramatically to 116,725 weapons produced in 1943. In 1944, even as Allied strategic bombing intensified and destroyed many factories, production actually peaked at 200,106 weapons manufactured. In the final chaotic months of the war, with Germany's industrial base collapsing around them, factories still somehow managed to produce 61,877 MG-42s in 1945. By the time the war finally ended, more than 400,000 MG-42s had been manufactured in total. Despite the original intention to replace the MG-44 entirely with the new design, both weapons actually remained in production throughout the entire war. The MG-34 continued to serve, particularly in specialized roles where its ability to use drum magazines was especially useful. But the MG-42 became the signature German infantry weapon of the entire conflict. The psychological impact on Allied soldiers was severe and well documented. The sound alone was absolutely terrifying to experience. Nothing in their training had prepared them for a weapon that screamed continuously instead of chattering in familiar bursts. Veterans later described in interviews the visceral fear that the sound induced. It was a gut-level reaction that was extremely difficult to control through discipline and training alone. But the actual reality was far worse than the terrifying sound suggested. At that blistering cyclic rate, a sustained engagement lasting just 30 seconds put more than 600 bullets into the beaten zone where soldiers took cover. Against exposed infantry caught in the open, the results were absolutely catastrophic. The weapon completely reshaped German infantry tactics and squad organization. While American and British doctrine emphasized the individual rifleman as the primary infantry weapon with machine guns providing support, the Wehrmacht built its entire squad structure around the machine gunner. German tactics placed the MG-42 at the absolute center of every engagement and firefight. Riflemen served primarily to carry ammunition for the gun, protect the gun crew from flanking attacks, and finish off enemies that the machine gun had already suppressed. A typical MG-42 crew consisted of 6 men with specific roles. The gunner operated the weapon directly, controlling fire and selecting targets based on tactical priorities. The assistant gunner helped feed ammunition belts smoothly and watched for threats that the gunner might miss while focused on his sights. He was also fully trained to take over immediately if the gunner was killed or wounded. One soldier carried the Lafette tripod for setting up sustained fire positions. 3 additional soldiers carried spare barrels, extra ammunition, tools, and other necessary supplies. Every single member of a German infantry squad understood clearly that keeping the MG-42 firing continuously was their absolute primary mission. The ammunition consumption was enormous and created serious logistical challenges. At 1,200 rounds per minute, a sustained engagement could burn through an entire squad's ammunition supply in just a few minutes of continuous fire. German logistics devoted considerable resources to keeping MG-42 positions continuously supplied with ammunition. Infantry units stockpiled ammunition at defensive positions whenever possible. Resupply operations prioritized machine gun rounds above almost everything else. But the weapon delivered combat results that fully justified the enormous consumption. In defensive positions, a single well-placed MG-42 could dominate open ground for hundreds of meters in every direction. In offensive operations, the gun provided devastating suppressive fire that pinned defenders in place, while assault teams maneuvered carefully to flanking positions. On the Eastern Front, where distances were vast and cover was often scarce across the steppes, the MG-42 proved particularly devastating against mass attacks. Soviet infantry attacks frequently ran straight into walls of automatic fire that shattered entire assault waves before they could close with German positions. Soviet soldiers quickly learned to fear the distinctive sound. They developed specific tactics designed to neutralize MG-42 positions before attempting any advances. At Monte Cassino in Italy, German defenders held the ancient monastery for nearly 4 full months. From January to May 1944, American, British, Polish, and New Zealand troops attacked repeatedly up the slopes. Each assault ran directly into devastating MG-42 fire from carefully fortified positions in the hills above. The defenders swept entire approach routes with sustained fire, cutting down wave after wave of attackers. The Allied forces eventually resorted to massive aerial bombardment that reduced the ancient monastery to complete rubble. Even then, German machine gunners continued fighting effectively from the ruins. In the Bocage country of Normandy after D-Day, MG-42 teams turned the thick hedgerows into efficient killing grounds. The Norman hedgerows were ancient field boundaries, dense walls of vegetation growing on earthen banks that divided the countryside into a maze of small enclosed fields. The narrow gaps between hedgerows became natural kill zones that favored defenders. A single MG-42 position at the end of a lane could halt an entire company's advance completely. American infantry learned very quickly to listen for the distinctive sound and take cover immediately when they heard it. The situation became serious enough that the United States War Department produced a training film specifically to address the psychological impact the weapon was having on soldiers. War Department Film Bulletin number 181, titled Automatic Weapons, American versus German, was released in 1944. The film was designed specifically to help soldiers cope with the fear that the MG-42 induced in combat. The narrator acknowledged directly that American soldiers were intimidated by the MG-42's distinctive sound. He showed footage of the German weapon firing, then demonstrated American machine guns for comparison. He assured viewers that the German gun's bark was worse than its bite. He explained that American weapons, though slower firing, were supposedly more accurate and more controllable. The film included a dramatized sequence showing a green replacement soldier cowering helplessly under MG-42 fire, while his more experienced comrades remained calm and continued fighting. The message was absolutely clear. Fear of the sound was a rookie mistake. Experienced soldiers supposedly knew better. The narrator concluded with the reassurance that American weapons were actually superior overall. "The German gun is good," he said, "but ours is better." Military historians later noted that the film was more propaganda than actual training material. The claims about American weapons being more accurate were questionable at best. The suggestion that the MG-42's high rate of fire somehow made it less dangerous was simply wrong. The reality was that the MG-42's bite was absolutely devastating on the battlefield. Tens of thousands of Allied soldiers were killed or wounded by the weapon during the war. The training film may have helped some soldiers manage their fear, but it did absolutely nothing to change the fundamental lethality of the German machine gun. On June 6, 1944, Hinrich Severloh demonstrated exactly what the MG-42 could do in the hands of a determined gunner with a clear field of fire. Severloh began firing as the very first landing craft approached Omaha Beach. He fired in controlled bursts of 6 to 8 rounds, sweeping the waterline where American soldiers struggled through the surf. He watched through the weapon's sights as men fell. He kept firing continuously. His assistant gunner fed belt after belt into the weapon without pause. When the barrel grew too hot to continue firing, they changed it quickly. Severloh had several spare barrels ready beside his position. When one ammunition supply ran low, soldiers brought more from storage deeper in the bunker. The American soldiers on the beach had no effective way to respond to the fire. They were wading through water that slowed them down. They were carrying heavy equipment that exhausted them. Many had been seasick during the crossing and were weak and disoriented. Their rifles were often waterlogged and completely inoperable. The artillery and naval gunfire support that was supposed to suppress German positions had largely missed its targets. Severloh fired for hours without stopping. He later recalled that he stopped thinking of the shapes on the beach as actual men. They became targets, abstract shapes to be engaged and eliminated. The MG-42 made it possible to engage so many so quickly that the human mind retreated from the horror of what was actually happening. By his own account, Severloh fired approximately 13,500 rounds of machine gun ammunition during the battle. He also fired around 400 rounds from his rifle when the machine gun needed barrel changes or reloading. American casualty estimates for Omaha Beach exceeded 2,000 dead and wounded on D-Day alone. German records and post-war analysis indicate that Severloh's position was responsible for a significant portion of those casualties. Whether his personal claim of killing or wounding over 1,000 Americans, possibly as many as 2,000, is actually accurate remains debated by historians. Many scholars consider the number implausible given that the total Allied casualties across the entire 6-mile length of Omaha Beach numbered around 2,400. What is absolutely certain is that MG-42 positions devastated the American assault waves on Omaha Beach that morning. Severloh's position at WN-62 was among the most lethal of all. The American response to the MG-42's combat effectiveness extended well beyond psychological warfare films. Military planners and weapons designers studied the German machine gun extensively after capturing examples. They incorporated lessons learned into post-war development programs. In the late 1940s, American ordnance engineers began serious work on a new general-purpose machine gun to replace the aging Browning designs that had served since the First World War. They examined captured MG-42s in minute detail. They stripped the weapons down to their component parts. They measured, weighed, and tested every single piece. They fired thousands of rounds through captured guns to understand their characteristics. The American designers noted several features worth emulating in future designs. The feed mechanism was remarkably reliable and efficient. The quick-change barrel system,